Welcome back everyone to my channel. So today I'm just gonna continue my climbing stair with min cost of climbing stair. So just to go through it, I have an integer of array cost where cost is the cost of I step on the staircase. So the 10 in here is step 0, 15 in here is step 1, 20 in here is step 2. Once you pay the cost, you can either climb 1 or 2 steps. You can either start from index 0 or index 1. Okay, I can either start at 10 or start at 15. Return the minimum cost to reach to the top. Okay, so let me go to the drawings so I can explain this more clear for you. Okay, so to explain the code a little bit more clear for you, let's say, as I said, the 10 in here is the cost, and this is at the stair 0. 15 in here is stair 1, and 20 in here is stair 2. So the problem asks us to find a minimum cost, either to reach to 20 or past 20. It means that reach to the top. Yep, so this is a dynamic programming, so definitely we're gonna have a decision tree. We can choose either 0 or 1 to start, or we can do from there, we can do 1 step or 2 step. Okay, so let's say I am at 0 right here. 0 is somewhere out here. So out here I can either choose 10 or 15, right? So in this path, if I choose 10, I can either choose 15 or I can choose 20, right? So if I choose 15, I will have a total cost of 25, and if I choose 20, I will have a total cost of 30 right here. So when I choose 20, it means that I already reached to the top, right? So this one we cannot go any further, so 20 will pop back to 10, but I will show it later. So in here I have 25. I can either choose 45, right? So I can either choose 20, which is the 2 right here, or I can choose nothing, meaning that I am at I equals 1 right here. So I can either choose 20 and I stay here, or I can go, I have bound right here, which is also good, which is 0 cost. So if I choose 0, I will have 25, right? And I will have 45 right here to reach to the top. So definitely from here, I know exactly that, 25 is the smallest, so I pop back 25. Let me choose another color. So I pop back 25 right here to our 10, and the 10 right here will compare like the 30 and the 25. So 30 and 25, so the 10 will pop back 25. So 25, as I know, is the smallest cost for me to reach to the top if I choose the path from 10, 20, 10, 15, and then 25. So now there's another path when I choose to start with the 15. So when I am at 15, I can either choose 20 or I can choose to go outbound, right? So in here, when I go outbound, I will have a total cost of 15, and when I choose 20, I will have 35. So let me just put the color in real quick. This is 20, this is 0. So now these two cannot it cannot go further. I will just pop back. So I have 35 right here, so I pop back 35. 15, I have 15 right here. So 15 is smaller, so I put 15 in here. 15 is a smaller cost, so to compare these two, 15 is smaller, so our solution at 0 is gonna be 15. Okay, so this is the brute force solution. So let me jump right into the code. Let's start to do our brute force solution. So firstly, I will have function dfs, right? So I will have an I here to traverse the cost array. So let's say if we are out of bound, so if I is greater or equal to the, let's say I need to have the length of the cost, so n equal to length of cost right there. And so when it out of bounds, I'm just simply return 0 because there's nothing in there. So next part is I just gonna return the current cost, right, plus like so for example, if I choose a 10, it's gonna be a current cost plus whatever left, right? So the DFS of I plus 1, so this is one step, right, minimum, and DFS I plus 2. Okay, so that is just basically it. Then in here we just return our DFS. We can choose either the first step or the second one. So this is the second one. Yep. And that basically it. Let's try to run to see if it's work. Alright, so it's work as expected, but this solution will have a time complexity of 2 power of n. So it's not really efficiency, and it's not gonna pass the LeetCode submission. So there's another way that we can do is we add a catch into this kind of problem. So we call it the top-down solution. It just simply I add a catch right here. So add a catch, right? This return right here, I'm just gonna simply put that in my catch, right? Then I am returning my catch, yes. And then in here I'm just gonna say if I in catch, if I already visit that node, visit that stair, I would just simply return that catch, so I don't have to recalculate it. So let's try again and see if it's work. Yep, it's work. But this is the top-down solution. There's gonna be one more solution bottom up, and let's jump right into it. All right, welcome back, guys. So I just quickly rerun the code and print out the catch. So as you can see, this is our catch, and let me jump right into the drawing path so we can come up with the bottom-up solution. Okay, so let's start with our bottom-up solution. As you can see right here at index 5 we have 23, and at index 4 we have 20, right? So these two right here is the minimum cost if I am at those index. So let me just quickly draw 1 2 3 4 5. So the 23, when we are at index 5, 23 is the minimum cost to get to the top, obviously. And then at 4 right here, the minimum cost to get to the top is 20. Why? Because we will compare, like if we choose to jump like one step to 23, the total cost would be 43, right? So it's not good. So we choose to jump right out here, which is 0. So the 20 is the minimum cost for now. And as you can see, this blank space right here, I just basically call it like 6. So this one will be always 0. So if I am at here, the cost will always 0. Okay, so just add a new one here just to let you know that. So now at 3 right here, I know it's gonna be 60. So where's this 60? 60 is the current cost plus the 20, right? So I would compare the current cost plus the 20, or the current cost plus the 2 step from it, right? So this plus this is 63, 40 plus 20, 60. So 60 is better. So that's why we have a 60 right here. So from print the catch, we know that there is a pattern, right? Let me just do one more example right here. At 2 right here, I have 4. So if I take this 20 plus 60 right here, I think it's gonna be 100. This is the two-step, or we choose to plus the 40 right here, which is 40. So 40 is smaller than 100, so we choose 40, right? So that's why it shows 40 right here. Again, with 11, we can either choose, let me just delete this real quick. So add 1 right here. We take 15, right? We plus 40, or we plus 60. So definitely the 40 is a better choice. So the total, the minimum cost from 1 right here is gonna be 55, right? And then from 0 here, we take the 10 plus 50, or we choose to plus the 40 right here. Definitely the 10 right here would plus 40, so it's 50. So 50 right here is the minimum cost from this 0 path. So we can choose either between the 1 or 0. Definitely 0 would be smaller than the 55. Okay, so this thing right here is gonna be our DP, right? It's gonna be our DP array with the length of, I believe, 7, right? So we will create everything from the right, go back to the left, and then we will find this. So let's jump right into the code and see how we do it. All right, so let's code it up. DP solution. So again, we will have the length cost, right? Then we have a length of the cost. Then we are gonna create our DP array, which is initially it's gonna be 0. Right? Then the last element in DP is always gonna be 0, right? In the drawing. So the next one will be always equal to the last cost, because when I am at that cost, I know exactly it will cost that much. Okay, I will go backward for I in range of n minus 2, right? Not n minus 1, n minus 2, 1, and going back. So this one, I'm starting from the second last element of it. So dp of I, right, would be equal to the min. I will compare the min cost between the current cost plus the dp of I plus 1, or the current cost, right, plus the dp of I plus 2, right? So just going backwards, bringing that out, and then in here I'm just gonna be return, I believe, min, the first and the second element from my DP, right? And let's just quickly run it to see if it's worked. All right, so it's worked as expected. If you like the videos, please hit the like button and subscribe. Help the channel a lot, and see you guys in the next video. Thank you.